Hello, hello, hello. Good morning or afternoon, everyone. Welcome to our live demo webinar. This one is particularly exciting. We're going to be exploring high throughput work cells that you can build with the Opentrons Flex and also utilizing, as you can see by us joined, by Retisoft with their software called Genera. My name is Nick Rizzo. I'm one of the product managers here at Opentrons, and I'll be presenting today. I have the pleasure of presenting today with Elizabeth Rodzowski, president of Retisoft, and Igor Landa, one of the application engineers from Retisoft. All right, I'm just going to pause here for a minute to make sure everyone who has signed up for this very exciting webinar has the time to join us. This is normally where I would kind of pitch the demo room, which I still am seated in here in New York City. Luckily, though, we get to rely on our fantastic partners from Retisoft to kind of highlight the flex that is on site there. And I'll allow Elizabeth to kind of intro that once I've kind of talked about the flex a little bit here. And let me just wait another second. But we should be pretty good to go here. Just a quick reminder to everyone online that this webinar is being recorded and will be made available on the Opentrons website. We'll also send out a copy of the recording via email following the webinar. To help with the overall webinar experience, all attendees are going to be on mute. However, there is a Q&A box towards the bottom of your screen, and you can enter in questions at any time during the webinar. We will kind of get to these all at the end, but please feel free to put in your questions while you are watching, and then hopefully as we answer questions, you'll also have some opportunity to put them in kind of at the end as well. Okay, fantastic. That's some of the logistics. Now, I really just want to thank Elizabeth and Igor and the whole team at Retisoft for working on this partnership. We're really excited to be able to offer expanded capabilities and really like possibilities for full workflow automation with the compatibility with Genera software. Today, we're going to be doing a demo, kind of just a kind of a simple example work cell showcasing this integration. And really we'll let Elizabeth and Igor kind of showcase what Genera software is, what allows it to be such an enabling feature, and how it works so well with the Opentrons Flex. And in that vein, what I am going to do is kind of just walk you through a few of the features that are going to be highlighted from Opentrons, and more specifically for the Flex that is going to be present, that is kind of showcased next to Elizabeth currently as they kind of walk through that demo. So the Flex overall, right, is kind of our flagship instrument here at Opentrons. It is in the current capacity there, showcased in kind of a higher throughput format. What this means is that we've added the 96 channel head to the instrument. We have two different options for 96 channel pipetting. We have a larger volume, so a 5 to 1,000 microliter pipette, and we also have a lower volume, 1 to 200 microliter pipette. Both are available and entirely interchangeable for any Flex that has already been kind of sent out to the field, or you have the ability to kind of order those kind of new. The other very exciting feature that is being shown on the Flex are our stacker modules. Those are located on the right side of the instrument. I've also got a couple here behind me as well. And what those do is that they allow you to greatly expand the tip capacity or plate capacity that your robot has access to in a fully automated fashion, while really minimally increasing the overall footprint, as you can kind of see here, of the Flex. And so With those, you have the ability to add up to 4 stackers in a really modular fashion. So you can have any combination of 1 to 4 in any of those right-hand slots. And each stacker has the capability of adding up to 7 tip racks. So 1 in the deck position and 6 in the tower. For a single stacker, right? So up to 28 that are going to be capable of being added to the deck if you have all 4 full of those. And they also have the ability to store consumables such as PCR plates, and you have the ability to add an additional 50 PCR plates per stacker with the addition of 1 stacker. The stackers also have capability to store as well as retrieve labware. So if you, as is going to be shown actually in this demo, you have the ability to kind of take labware out of the stacker and then also replace labware back into those stackers. So they are bi-directional in that capacity. So you have the ability to kind of work on them on the deck and then store them back into it. It is kind of first in, first out. So you do have to plan for that within your protocol, but you do have the ability to kind of move things in and out, which is very exciting. They open on kind of the right-hand side of the instrument and are very easy to kind of manipulate to either take those plates and tips into and out of the stacker. And we are really, really excited to be able to kind of showcase what these look like kind of in conjunction with this kind of more robust and kind of more expansive system that Retisoft is highlighting here in this kind of workflow. A few other things about the Flex that are going to be highlighted in this. The robot that is next to Elizabeth there will also showcase the Flex Gripper. This is able to move labware and other consumables across the deck as long as they are SBS format. It has access to the stacker kind of transit positions so that as things come out of the robot, you have the ability to move them around the deck so that you can perform different functions with them. Here, this is particularly helpful. As you can actually see the robot is doing now. That plate will be picked up and moved, and then eventually will be moved to another location that allows the robotic arm that is being controlled by Genera to have access to that plate. So it actually allows kind of a further utility of the system in this like really interesting, almost like dual gripper kind of functionality. Also on the deck is a temperature module. We have a variety of modules that are available on the Flex, including a temperature module that goes from 4 to 95 C. We have a heater shaker module that can shake up to 3000 RPM and goes from ambient plus about 2 degrees to 95 C. We also have a thermocycler module that can allow fully automated thermocycling to occur within the robot space, as well as an absorbance plate reader and the stacker modules that I have kind of just showcased there. We also have a HEPA UV that can go and sit on top of the instrument to provide a sterile environment as well. And that is kind of the overall kind of configuration that I wanted to touch on for the Flex. The next thing that I want to just touch on from an Opentrons perspective before handing it over to the Retisoft team is to quickly talk about some of our kind of installation and protocol development feature sets. So as you can see, there is a kind of a larger workstation configured here. However, Opentrons is still going to be involved in this process, to install something like a kind of a fully functional work cell like this. What that means is that we'll still be responsible for kind of coming on site to do the installation of the Flex, and then also, depending if you have purchased it, to perform some protocol development as well. And so in that, you'll have the ability to kind of, interact with one of our field application scientists and start to build out from your kind of, either other automated or manual SOP, what your protocol should look like as it executes on the Flex instrument itself. Then that protocol can actually then be wrapped up into a larger workstation configuration by somebody like Igor as they build out what this kind of, all-encompassing, protocol could look like as you incorporate other devices and kind of have a full ranging work cell. Okay, now to move on from my rambling and to move to the very exciting part of to show you what the robot is actually doing, I will be more than happy to hand it off to Elizabeth.
Thank you, Nick. It's a pleasure to be here today, and thank you for inviting us to be part of this webinar. You've done a great job already explaining the capabilities and all the benefits of the Opentrons Flex. And we put together with our team here at our headquarters a demo system to showcase the capabilities that we can bring up together with the Opentrons, with the robotic arm and the Genera software that we will explain further later on in the webinar. So the goal with this workstation is to build a modular, scalable as well, and vendor agnostic automation environment. So you can really benefit from choosing the different devices that you will need depending on the workflow that you're running. And that I'm going to talk a little bit more about as well. But one of the things that I think with Opentrons and Retisoft, we really work together on making automation accessible to every lab. And that's what our mission as companies are. And that's why our partnership works really well, because we want to be able to enable that automation for every lab in life science, regardless of the size of the lab and the type of the workflow that they are running. So in this demo system that we have here at our office in Canada, we are showing a very flexible automation platform. This complements the Opentrons Flex really well, together with the plate stackers that Nick has mentioned, that really increases the throughput of the Opentrons, but we can also add more external plate storage, and that's what we're showing here today. And with that, we can also fit this workstation in a very small footprint. So we can, as you can see here, this could fit on a lab bench already in your lab, or we can, at Retisoft, our team can design and build the workstation that fits your laboratory space. So there's a lot of configurations that we can work with, depending on the type of devices that you also want to integrate in the system. So Genera, that's one of the flexibility advantages that we give you with Genera and with our robotic arm Precise Flex. So talking a little bit about the robotic arm, Precise Flex robot is quite of the standard nowadays. For over a decade, it has become the standard in the laboratory automation mainly for their design, the compact design that it offers, as well as the safe operation and precision that it brings to the system and the handling of the microplates and samples. So to enhance those features of the robot, we have built our own teach pendant in Genera, which also gives you a lot of power when you are integrating the system. One of the benefits of that is that you can easily configure the system and then teach your positions and add equipment as you are growing with your workflow and your work cell as well. So we will basically provide that together with Genera. It's embedded in Genera. Igor will show a little bit about the teach pendant, but we also have done a full webinar on the teach pendant capabilities. So if anyone is interested later on, they can contact us and we can give you a demo of how Genera integrates with the Precise robot. And so our solution here basically includes an external storage, room temperature storage, the robot, and the Opentrons Flex, but it is not limited to that. With Genera and with our solution, you can add many different types of devices. So let's say about temperature control storage, plate readers, for example, plate sealers and peelers, shakers, incubators, dispensers, and many more. So it will all depend on your workflow, and we can design that system according to the workflow that you are running. We can design the configuration of that system, as I mentioned before, because it becomes, it's really easy to work on different configurations together with the Precise robot and the tables that we have built in a modular way. Now about what it's controlling everything in the system. Genera integration framework, it's an entire product that we have been developing for multiple years at Retisoft. And we also have quite a large library of instrument drivers. Currently, we have over 200 drivers that are supported by our team and compatible with Genera. And because we're vendor agnostic, we give you the flexibility of choosing the devices that fit best for your workflow. And it makes your automation experience very easy and seamless to deploy. So with this level of flexibility that Genera has, the tools that we have embedded in Genera, like the Teach Pendant, the Instrument Viewer, and many others, really increase the capabilities of the entire solution. And that's where we want to showcase as well today. And I will hand this to Igor at this point, where he can demonstrate how we have set up the workflow for this system here. Thanks.
Thank you for that, Elizabeth. So today I'll be giving a high-level overview of Genera, specifically focusing on the interaction between Genera and the Opentrons Flex. So we've done plenty of webinars in the past, and later on in the presentation section of this webinar, we'll provide a link if you want to book a demo to go into any specifics. So first, what we're looking at here is our scheduler view. So this is our dashboard view. So the top left, we see that tasks that have run, is running, or is going to run. In the top right, we have our task details. We have our batch chart, logs, workflow, and variables. And we could see them here with the values. On the bottom, we have our workspace layout, which models the system, and Genera is a dynamic scheduler, so it'll keep track of resources and plates to make sure that there's no collisions or errors. So we could see here that it's a little bit hard to see since the Opentrons is covering the camera, but it'll model what's on the Opentrons deck layout. So we can see one plate there, and one plate is moving from the stacker to slot B2, and you can see that the plate is loaded up there. So next, how to configure this workspace layout, we're going to go to the editor tab. So this is our workspace editor, and this is all a drag and drop. So if you add a new node, for example, a nest into our workspace, to configure it, we would need to give it a name, any labware rules, zones. Those zones is a way of pulling instruments or locations for labware, and your instrument here. So you just select your instrument and then you add it to the workspace. Next, we have our projects. So projects, we define our labware definition, any labware operations we'll have that will apply on the labware, and any zone. So this is where you configure that. And then finally, as Elizabeth mentioned, this is our teach pendant here. So all teaching can be done through this pendant, including you could test the path for your teach points. So you can go forward and backward. You could step through it, or you can move directly from safe to nest. And as I mentioned, you don't need to move around at all. For teaching, everything is here. So I know that was fairly fast, but as I mentioned, we'll have a demo link if you want to go into any specifics. But this is where I want to spend majority of our time, which is our process editor, and show how Genera could not only interact with the Opentrons Flex, but enhance the capabilities of it as well. So within our process editor, the first thing we have to specify is our lanes. So lanes had about 90 to 95% of the time is associated to a particular labware for one time, or for one time through in your batch, which is how many times you're running through your process. So in this case, we have 2 plates and 1 tip box for one protocol. So we have our source plate destination if you're doing any hip picking or cherry picking, and then a tip box, which will unload from the stacker and reload into it. And so the first thing you have to specify for a given lane is our labware node. So our labware node is a control node, which we'll see on the top left here. So control nodes have some sort of control for the process. And we could think of the labware node as a type of funnel to find the correct labware in your workspace. So the first two criteria are our location. So the mandatory one is the location. So in this case, our source and destination plates are located in stacker B4. Our labware definition, so what type of labware are we looking for? And we could do further criteria, such as if we're looking for a labware that is lidded or not lidded, what kind of operational status is on that labware, barcode. So if I want to look specifically for a source plate with a source plate barcode, I can specify that here. Or I could do a custom script for criteria. So next we have an unload stacker activity node. So activity nodes are on the bottom left here, which are instrument specific, or there are some broad general activity nodes that are useful, that we found are useful for users. So for example, we could send email, we could set variables from CSV, we could have a timer. But in this case, we have an unload stacker. So all of these nodes are drag and drop. So if I want to add a node, I just need to, for example, move it into my process editor and then specify the parameters for that specific node. So if we look into our unload stacker, we could see that we're specifying the instrument. So which Opentrons Flex so if we had multiple Opentrons Flex, which Flex am I going to use for this activity node? Our destination, which is the slot A2, and our unload, and then what protocol file are we using? In this case, I have a protocol file named unload stacker. And what's so powerful about this is that when Genera runs this protocol file, it's going to send parameters to that unload stacker. So for example, it's going to send the source, the destination, and the labware type. So if we go back to our workspace, go back to our labware definition. So within our labware definition, we have an Opentrons labware type. So as we could see, the value for this Opentrons labware type for our microplate is our Opentrons 96 well plate, 200 microliter PCR full skirt plate. And Genera will actually send that information, so depending on which plate is associated with that lane, to the Opentrons, as well as the source and destination locations. So we could use this unload stacker in multiple cases without having to change the method that it's being run. So anytime we unload from the stacker, we could just use the unload stacker activity node. So nothing needs to be changed on the Opentron side in that case. So next, after we unload all three of our plates into their respective locations, we run our protocol. And just some information about these lines here. So these are links. So these are ways that different lanes can interact with each other, because in this case, all three lanes are going to run at the same exact time. But if we want to make sure that the three lanes or the three plates are in their respective locations before the run protocol is run, then these links will ensure that. So this run protocol will wait until these two have finished. And then these two activity nodes, after the run protocol for the destination plate and the tip box, will wait until the run protocol is finished. And if we look at our run protocol here, we can see that we specify the instrument. So if we have multiple Opentrons Flexes, our protocol file. So this protocol file is set to a variable instead of a value, and it's set to this Opentrons protocol. So I'll demonstrate that in a few seconds, but this is basically a Genera variable, a parameter variable that could be specified at runtime. We could specify any custom labware with a JSON file. And then we could also set custom runtime parameter names and values. So for this for this transfer, so this run protocol just simply moves, aspirates from the source plate and dispenses into the destination plate using the tip box. In this case, I'm specifying the volume, and the volume is also a parameter variable, so that means it's user defined. And then finally, after we're done with those three, or after we're done with the run protocol, we go to the next activity node, which is our move labware. So this move labware, so you specify a mover. So in this case, we're specifying the Opentrons Flex and then the destination. So I'm moving the microplate from the A2 slot, which is not accessible by the arm, to the A1 spot because I want it to be accessible. And we can see here that and even here, we don't have to specify a protocol file. And the reason is because within our scheduler view and our instrument panel, if I was to expand it to see our control panel, we could see here for the Opentrons Flex, we have a move labware protocol. So here we specify that move labware protocol, and as long as the parameters include in that protocol the source location, destination location, and the labware definition, similar to the unload, then we could use this move labware node to do any movements within the Opentrons. And so as we could see here, that the only thing we have to customize if we start a new protocol is this run protocol. Everything else that has to do with unloading stackers or moving plates on an Opentrons can be done inherently in Genera. And so that can make method development a lot easier. So for example, let's say that I want to add an intermediary plate or an intermediate plate to my process. And so I want the process to go from the source. I want the process to look like the source plate or the Opentrons aspirating from the source plate, dispensing into the intermediate plate, and then aspirating again, and then going to the destination. If I want to do, for example, like a serial dilution. So all we would have to do is specify a new lane, which is the intermediary plate. And as I mentioned, and to add another layer of complexity, what I want to do is make this optional. I want to make this optional at runtime, where some users may want an intermediate plate, but some users may not. So in this case, I need to specify a variable, or I already have this variable here called intermediate, and it's a Boolean type variable. And we're just going to set it the default value to false. And we're going to have it be a parameter. And so now what we do is we add a decision node, and we look for whether the intermediate variable is true. So if it's true, that means the user wants an intermediary plate. So we're going to go through the true lane. If it's false, then we're going to do nothing. So we're just going to keep on going with the source, destination, and tip box. And so first thing we specify is our labware node. So this intermediary plate is going to be located in the stacker B4, and it's going to have the same labware definition as the source plate and destination plate. So we just specify the microplate. And then we want to unload from the stacker. And the first two plates, so the source is going to go to slot A2. B2 is going to be occupied by the destination plate. C2 is going to be occupied by the tip box. So I'm going to select D2. And then I want to link this. So you can't do links within decision nodes. So after this, I'm going to link this up to my run protocol. And then to make this look a little bit nicer, I'm just going to move these over. Here we go. And then I'm going to make the same decision node on the other side. So after the run protocol is finished, I'm going to look at the same exact decision. And then I'm going to link this back down. And then we're going to move the intermediate plate to our C1, because A1 is going to be occupied by the source, B1 is going to be occupied by the destination. And then the mover is not the PF400, but the Flex, because I'm moving it internally within the Flex, the Opentrons Flex. And then finally, let's say I want to discard this labware. So I'm going to add another move labware into here. And we're going to specify now the PF400. And instead of a move, we're going to have a discard method here. And we're going to discard it to the trash. And as you can see, so if I was to, for example, going to run this process, what I'm going to do is I'm going to schedule next. So these are just scheduling configurations. So batch count is how many times you're going to run through this process. So in this case, I'm just going to say 1. And then for start, I could have it start at different time or a different start conditions. For example, I could wait for user input. I could do specific date and time or after a task finishes. And then I could also specify recurrence. If I want this process to run a certain amount of times at a certain time interval, so kind of like an Outlook calendar or weekly Outlook meeting. So I could specify this to run on weekly on, let's say, Wednesdays and Fridays. Or if I want to do QC in the beginning of the week, I could set it to Monday. But the important part is the next part, which is our parameters. So this is our setup page. So we could customize this page to make it look, or to make it look how you want it to look, or you could have it be an SOP for new users. So those could be set here. But the important thing is, we could specify the Opentrons protocol, and we could have a hint here to show what this parameter means. So in this case, it's to browse to find the Opentrons protocol. So in this case, we can see that it is the liquid transfer method, but this is not using an intermediary plate. So I'm going to select my liquid transfer with intermediate plate because that's the only thing we need to change on the Opentron side. And then I can specify my volume. So let's say I want to just transfer 1,000 microliters, serial dilution. And here, set this equal to true. So now this will go through the true condition within my decision node. And it's that simple to add a second or a third plate or to modify an existing Opentrons, or without having to modify all the Opentrons method. The only thing I need to modify is the run protocol. So we can have the same method, or the same process within Genera, just have a few tweaks here and there that the user can define at runtime to make one user have a different process than another user. And the last thing I want to show on the Genera side is our user management. So we have user management within Genera. So if I was to go to manage users, we could see here that the only user I have here is my admin. But if I go to the roles, I can see all the different roles within that I have specified. So let's, for example, go into guest. So for guest, the only thing they're allowed to do is open processes and open programs. But these could be editable, as you saw on the guest side, or let's say for integrator, they're allowed to run open and schedule processes and so on and so forth. But I could check things off. I could say, let's say they can't open up programs. And then I could add that integrator to here. And then in order to log in, all you have to do is when you first open up Genera, nothing will be logged in. As you can see, if I'm not logged in, everything gets grayed out. So I can't schedule, I can't save anything. But once I log in to my admin account, we can see that now things are not grayed out anymore. And so that's what I wanted to show on the Genera side. So before we move on to Q&A, I'm going to share another screen. There we go. So I'm going to go through this quick presentation, going over a few things about Genera. So we have first of all, we have Genera editions. So we have 3 editions: our Genera Lite, Genera Standard, and Genera Pro. So each edition is flexible and adaptable to your needs. So let's say you're a small startup lab that has limited funding and you need a small integration system, kind of what you see in at the office behind Elizabeth with a simple workflow, then Genera Lite would be a perfect fit for you. But if you're a large lab that has a complex workflow with multiple robot arms with 20+ instruments, then Genera Pro would be the right fit. And you could start at Genera Lite and upgrade to Genera Pro as you get more hardware or as you're building out your workcell. And the last two are links. So as Elizabeth said, we have a driver list of over 200 right now. So you can see that list here using this QR code. And as I mentioned before, if you would like to book a demo to go into specifics of anything that I mentioned during the overview, then you could scan that here. Next slide. Yep, so to go a little bit into our support. So with every license purchased, it comes with 1 year of support, including with that purchase, and you have access to the Retisoft Hub, which I'll explain what that is in the next slide. We include software maintenance and support, and it includes any software and driver upgrades and maintenance if there's a support contract in place, and then there's custom development upon request. And the most important thing, in my opinion, is the responsiveness of the support process. So you could contact us via email, phone, or schedule a remote support session, and you won't be met by any AI at Retisoft. Every email that you sent will be sent to a human being, and we'll get back to you as soon as we can. Yep, so as I mentioned, this is our Retisoft Hub. So this is our online training platform for users to master Genera. So in this Retisoft Hub, we have training and tutorial videos for all levels of expertise. We have a user community forum where users can interact with each other and ask any questions, and other users can answer them. You could be informed of upcoming webinars like this one and other events, and then get updates on new releases, features, and improvement as we're actively creating new releases and fixing bugs and creating new features. So this right here is our light automation bundle. So kind of what you see in the back of Elizabeth, we have this bundle includes a robot arm, 3 hotels, a platform, and the Genera Lite with 3 instrument connections, not including the arms. The arm does not count as an instrument connection. It is embedded within the license. So this is a nice solution for any benchtop applications that have limited hardware. So you could have the Opentrons on one side, and you could have a reader or flow cytometer, any data analysis or storage if you want to increase the capability or throughput of the Opentrons and the stackers by themselves. And last thing is Opentrons and Retisoft will be at LRIG, New England, and which is on October 28th, and you could scan the QR code here to RSVP for it. And yeah, hope to see you there. And finally, I will bring it back to Nick to facilitate the Q&As.
Great. Thank you so much, Igor and Elizabeth. Again, super excited about this. Really cool to get the rundown on Genera. And yeah, let's jump into some questions here. Okay, first one. If I own the equipment, I think probably just more generally, but also when I selfishly say maybe the Flex, can I just purchase the Genera software? Elizabeth, probably you on that one?
Yes. So thank you, Nick. Yes, absolutely. So if you own the equipment, you can purchase the license, Genera license, as well as if you need any external plate storage or the robotic arm, we can provide a quote for that as well.
Okay, awesome. Thank you, Elizabeth. Oh, another good one here. What devices does Retisoft support? I know that you had kind of mentioned a few of these, Elizabeth, as you were kind of talking through that.
Right. So we have like we mentioned before, over 200 drivers already available in our library. You can go to our website. Igor showed briefly a code for QR code to go to the link on our website, but you can go to our software section in our website, and there you will find the list of drivers that we currently support. If there's a need of developing a new driver, we also have that service with our team. We can develop drivers for new devices or updated devices as well.
Perfect. Okay, great. Yeah, I have been on the webpage for that. It is definitely very impressive. So there are a lot on there. Okay, great. Okay, for both Opentrons and Retisoft systems, if an ongoing screening campaign is running and the Genera platform is using the Opentrons liquid handler, can the user pause the automated run, switch to manual mode on the Flex liquid handler to perform a basic plate replication method, remove these process plates, and then resume the automated sequence with the remaining plates? So essentially just to kind of intersperse in kind of a more typical Opentrons kind of run within a larger kind of workflow. Igor?
Yes, you can. And let me see if I stop sharing this screen. And I share my Genera screen, I could show you how that could be done. So as you can see, that we have a process that's currently running at the moment. So we have within our task, we have different options here. So we could pause scheduling, and we could pause scheduling and execution. So if I was to just pause scheduling, after it's finished running what it's currently running, it will pause the entire process, and then this will turn yellow. And when this is paused, I could uninitialize this instrument, and then you could use it standalone or run whatever method you want to run. And then when you're done with that, you could reinitialize it. Oh, there you go. So you can see now it's paused, nothing's moving. You can see here that the workspace is frozen with 2 plates on there. So now I could uninitialize this, and then I could run it manually. Or what you could also do is you could run individual commands while it is paused, and those commands will run. So you could run a protocol, for example, in the Genera software, and then whenever you're done with that, you could resume it, and then it'll keep running. So I hope that answers your question.
Yeah, really cool. Thank you, Igor. Let's see. Are those Move Labware Python files pre-built in Opentrons? Igor?
They are not, but that's something Retisoft can provide. If yeah, it'll be provided by Retisoft if you have an integration with an Opentrons Flex.
Okay, fantastic. Okay, a couple more questions coming in for Retisoft. What new or upcoming features in Genera will incorporate any AI-driven capabilities? Specifically, can Genera leverage AI to analyze reader data in real time, make autonomous decisions based on results, automatically reprocess samples by retrieving the appropriate source plates for handling on the Opentrons Flex platform? So I guess, yeah, just more generally, if and how Retisoft is planning to incorporate, got some AI, and it sounds like specifically AI analysis toolkits. Elizabeth, I probably think that one's for you.
Yes. So Genera currently has we make decisions during the run, so it's an intelligent dynamic scheduler. So it does take information and makes decisions based on the inputs that we give it. We also have a REST API, so we can integrate, or other companies and customers are doing as well, integrated with external software or platforms that they use internally to increase capabilities of the software, so we can push information or data to certain files that the other software can use. At that point, it's more like an external integration. It's not built into Genera, but we enable that integration through our API as well. I don't know, Igor, if you want to complement the answer to something else, but
Yeah,
that's
so
what we're currently.
What I've seen from customers in the past of using AI with Genera is they will run like the parameters through their AI model or whatever the LLM, and then whatever parameters those spit out, they will use the remote API to send them over to Genera. So let's say they're doing something that requires like specific incubation times. You could have the incubation time be a variable and then have that go through your LLM and then have it spit out and send that to the Genera process. That's one way. That's more indirect. Yeah, I would say that's the main way that AI has been used with Genera to kind of like close the loop.
Okay, cool. Thank you so much. Another AI question here. This one for me. What AI capabilities are currently available or in development within the Opentrons ecosystem? Can you share any details on how these might enhance decision-making, adaptive scheduling, or closed-loop automation workflows? Yeah, absolutely. So we have our kind of protocol authorship and kind of protocol revision tool, Opentrons AI. And so this is available for anyone who wants to go navigate to this and use it to either modify protocols, as I've said. It's really good at revising them and kind of performing some other functions like updating runtime parameters, which then Retisoft can interact with. This is all kind of very like directive though, right? From an authorship perspective. In terms of kind of future leaning features that kind of adapt more decision making, kind of some of these analysis tools and closed loop automation workflows, those are absolutely something that like we are continually investigating, right? And are actually building out roadmaps for right now, to enable us to kind of assist in some of those, the more manual processes that are involved with a lot of that kind of data acquisition and handling, and to try to automate that and kind of push the automation kind of further upstream or downstream, I should say. And so because we are, from the Opentrons perspective, kind of built entirely in Python, right? There is kind of this, larger ability to interact with different Python packages that would enable, kind of like some more interesting control. But I would say like, it is definitely still, something we are deciding on. I think things like the interaction between Opentrons software stack and Retisoft, Genera, and kind of scheduling companies like that, right, is where we kind of look to bridge that gap into the adaptive scheduling kind of field, right? Opentrons on its own does not have that kind of scheduling capacity. And the other one, right, is that like we don't have the same interaction with analysis devices that Genera does. And so a lot of that, though, is just kind of like higher level, like data manipulation and logic. And again, because we're in, Opentrons is in Python and we have that as a language model, right, that we can build and train off of, we do have this like really fantastic starting point. And so that is all to say that like, I think we're still thinking through like what these things can look like. How can we start to grasp onto them as we integrate with more devices, as we integrate with more partners, right? And then look to provide tools. Constantine, if you have any specific ideas around that, obviously would love to set up a call and discuss and kind of talk through some of the pain points that you have and to brainstorm. I know that as the product manager here, always, kind of vying for some free voice of customer. So that would be fantastic. Okay, great. Can the integration backbone of protocols be Python or Bash script based? Igor, probably for you.
Yes, the backbone for a process is an XML file. So that can really be changed. What you can do is using the remote APIs, call the process files using Python, but the backbone of it is just XML. Is just a .xml file. So it could be editable if you know how to manipulate them.
Yeah. And then just from the Opentrons perspective, I think that this is mostly Retisoft focused, but yeah, protocols from
Yeah.
the Opentrons side are always going to be in Python. Let us know, Hannah, if there's any further questions on that. And as always, you can reach out to a representative from Opentrons or Retisoft to kind of further answer some of those questions. And as Igor had said, if you need like a further demo and to really dive into what your specific use case is, I will readily sign Retisoft up to do that for you. Okay, another question here. The Genera driver list, someone went and checked out at our at our suggestion, which is fantastic. Someone's doing their homework in real time. That the list includes the OT2. Would a system that uses that instead of the Flex operate similarly minus the gripper functionality, or are there more significant workflow or communication differences? Igor?
I would say it works very similarly. So Genera doesn't really create protocols as you saw. It mostly just calls them. So same with the OT2, it would just call whatever protocol you made using the Opentrons platform. And yeah, so it just worked very similar. It might not have, for example, like the unloader or the move lab where because, as you said, the OT2 doesn't have the grippers, but yeah, it would work very similarly.
Yeah, and then just to add on to that, so the stacker modules are only compatible with the Flex. They don't work on the OT2. The kind of main basis for that is that the gripper isn't present, so you wouldn't be able to utilize them in the same capacity kind of whatsoever on the OT2. And so kind of the yeah, as you were said, like the core structure of the protocol would be significantly different on the OT2 versus the Flex. But if you were to look at something like, just the liquid handling elements, yeah, like that protocol that would be called by Retisoft, right? Could be the OT2 or the Flex, as long as things are like plate positions and all of that was also kind of like, figured out and adjusted accordingly. Okay. Next question. Looks like this is the last one for now. So if anyone else has other questions, please get them in. Okay, cool. Is it possible to set different variable values for different batch runs? Igor?
Ooh, that's a great question. And the answer is yes, you can. That's something I did not show, but I could quickly show. So if I schedule the same process here, so let's say I now have a batch of 5. So within the variable table, you could set variables as either batched or not batched. So you can see that the Opentrons protocol and the volume are batched and the intermediate plate is not. It should be, but I did not specify that. And if you select it, you can see that now I could specify different batch values for all 5 of my batches. So in this case, let's say the third batch, I want to change this to the liquid plate for intermediary. Now it's changed. So, and then for the volume, let's say I want to change this one to 5 microliters instead of 1. So, yes, you can.
Okay, fantastic. Thank you, Igor. Okay, cool. We don't have any other questions typed in. I do see that someone has their hand raised in the attendees. And so if you do have a question and you have your hand raised, please feel free to type that in. I can just vamp for another few seconds here. If not, as I had said previously, feel free to reach out to an Opentrons representative or to the Retisoft team for any questions with that. Otherwise, thank you so much, everybody, for joining. And thank you again for Retisoft for doing the heavy lifting of setting up this really cool system. It is so exciting to see the Flex kind of in this kind of capacity. And yeah, really, really excited to see all of the really cool projects that we are able to kind of perform together. Okay, great.
Thank you so much, Nick.
Yeah, of course.
Thank you, Nick.
Yep. No other questions coming in, so I think that we can probably go ahead and end it. Thanks all.